Hello, everyone. My name is Omar. I am a master's graduate student from Hamad bin Khalifa University, and this part of my master's thesis for data science and engineering. So we built a robust Hadith IR using knowledge graphs and semantic similarity classification. So Hadith is the term used to describe the narrations and sayings of the Prophet Muhammad, peace be upon him. And the study of Hadith can be modeled into, well, a pipeline of tasks performed on collection of textual data. The work of this research will demonstrate how the Hadith IR can be more efficient and insightful using a user-centered methodology. And this whole domain is quite largely underexplored area with great potential. So I will go over the introduction background about the domain, as well as literature review of common of previous works in this area, and then I will just go over the methodology and the proposed solution that we have, as well as the results, and finally I will conclude my presentation. Right, so Hadith is the main term, as I said, to describe the narrations of actions and actions of the Prophet Muhammad, peace be upon him. Hadith is very highly valued by the Muslim population. It's considered to be the second source of legislation after the Quran. In its classical form, the Hadith has two parts, the Sanad and the Matan. Sanad or Isnad, that's the blue part, and then the Matan, which is the yellow part. The Isnad is the route of information for the reporting individuals who have transmitted this story or event, while the Matan is the actual saying or the actual event itself. So in this case, for example, we have a narration that goes narrated by Yahya, Qutayba, and Ibn Hujr. They all said narrated by Ismail from Al-Ala, from his father, from Abu Huraira, from the Prophet, right? And then the actual saying of the Prophet himself. So intuitively, we can actually construct a directed graph where we have these narrators, Yahya, Qutayba, Ibn Hujr, from Ismail, from Al-Ala, from his father, from Abu Huraira, as we just as the text itself. Right, so this is one part of the hadith itself. The second part is the actual saying narrative. So in this case, we have two-dimensional representation of the same textual data. One dimension is, or one part of it is a semi-structured part, and the other part is the natural language, which is a non-structured data. Now, hadith scholars, whenever they came into this phenomenon, they were mainly interested in evaluating the credibility of the source of this story ever happening. So based on that sanad construction, right? So they have a series of tasks. One of them would be to check for the connectivity of this sequence of the sanad. So for example, every individual here needs to meet the individual they report from, and etc. as you go until you reach the end of the chain. However, sometimes if it's disconnected, the whole attribution or the whole referencing falls apart, and then the entire story will be rejected. Another task that the scholars are also interested in is to evaluate the credibility of each of these narrators. So, for example, if this was narrated by someone who is he's a known liar, for example, or documented for telling lies even once, the entire story will be rejected if they were part of the common link. And there are many different tasks that the Hadith scholars have documented. So in order to perform these evaluations, it's very labor intensive, and it's quite challenging due to the volume of the Hadith library, because there are hundreds and thousands of narration instances. Therefore, information retrieval is perhaps the most significant problem for the entire domain. Now, many of these tasks, they do actually match known NLP problems. However, the current existing solutions for the Hadith applications that they have, and that's it for this domain, they are quite limited for two reasons. First of all, they only offer a text-based retrieval, and as we described, the Hadith is quite interesting for its semi-structured part, which is the isnad itself. While none of these solutions, they offer anything in that regard, unfortunately. Secondly, all of these solutions that currently presented in the commercial market are repetitively manually annotated by annotators, by specialists, which is very expensive, of course, and it's time consuming. It's not scalable at all. When we conducted the research in this domain, there are a couple of challenges that we faced. First of all, the literature in the computational problems don't seem to have a clear idea on what are the user needs of the domain. So there's a gap there, and we were able to fill that gap by our user-centered methodology, because we sat with users and we documented. We conducted our constructive or semi-structured interviews to define a clear user need for the domain. The second challenge that we have when we did the research in this domain was that this entire domain is data dependent. However, there is a lack of any available data sets for research purposes. So we had to scrape one of the sources in order to gather a data set that's locally that we can start working with. Right. So in all of Hadith IR, we are interested in a specific problem, which is known as the Takhreej or Takhreej group retrieval. The focus of the problem is in collecting all of the instances of that same story from all of the sources. And this is actually primarily used by the scholars before they begin any of their investigation to maximize any information gained before they start the evaluation. So within the Islamic library, there is a bunch of books that is known as the Isnadic books. They have this attribution of having isnads. Not necessarily all of them are hadith, but the ones that are hadith, they are attributing to the Prophet, but there are existing other books that uses the same references. So it's a quite large domain of Arabic literature. And within the hadith books, there are a bunch of collections that are used. And this is the details of these scopes is defined and is detailed in our paper as well. Right. So previous works, well, the computational research for hadith has been going on for quite some time now. It was old, but the efforts are very minimal. Unfortunately, it's very limited. So Muhammad Mustafa al-Azami, he pioneered the efforts of hadith computational research since 1978. Up to date, we have about 7 active hadith commercial softwares. There are much more than this, but these are the latest ones. Previous ones are hardly mentioned in by any of the users. The comparison between these different applications is also available in the paper for anyone who's interested. Bowen has in 2019 he surveyed 80 different papers in 4 hadith and classified them into several problem spaces, and he illustrated that anything related to biographical analysis or information retrieval or data visualization is understudied, unfortunately. He also illustrated that there are few masters and PhDs that were published in that domain, and they actually led the recent publication efforts. However, none of the masters and PhDs are available in English, unfortunately. All of them are in French. I think there are about 4 or 5 different works so far. So our work is the first master thesis that is available in English. So we classified all of the hadith retrieval works into 4 different groups. Topic clustering, which is basically works related to training the model to recommend and generate topic labels. So it's a very simplified problem for retrieval. And then other researchers, they tried to do or attempted to do a regular expression querying. So they improved the querying process to have more power, more expressive querying language. However, they only implemented this as part of the backend implementation of their Android app, rather than providing this directly to the user. So the search options they provided include searching using the word of a root or root of a word, or controlling the order of the words or the sequence of words appearing in the text. However, nothing related to chain pattern search was explored by previous works. The third group of papers is the narration metadata search. So there are a couple of papers about ontology construction using the description logic query. So they search about meta properties of the text rather than the actual text itself, which is also can be used for Hadith retrieval. And lastly, we have some works related to Hadith recognition and extraction. I have to highlight that the commercial software right now, all of them, they are manually annotated. And the latest one is the Lifta. It was annotated by about 200 annotators over 6 years. It's a very massive project. So a group of researchers, they propose a crawling system that extract hadith from web pages and look up their degrees and their predefined assets. So these are different techniques that are currently used in the literature for hadith retrieval. However, none of them seem to be satisfying a clear user need in the domain. So in our methodology, the first thing that we needed to do is to define the user needs. So we surveyed the computational works available as well as the other commercial tools and what's their capabilities. We conducted semi-structured interviews with that included 3 domain experts with 20 years of experience in this domain, as well as they teach and train people on how to do research in hadith at university levels. Then we constructed a querying use cases and scenarios to have a very clear idea on what's the user need is defined as, which later on will be used for our evaluation of the proposed solution. We observed 10 users of variety of levels in performing such tasks and how would they retrieve manually all of or even using current existing solutions. How would they retrieve all of the hadith instances for the Takhreej group? And then we evaluated our proposed solution using a task-oriented approach. So we have 2 solutions that we have proposed in our paper. The first one is a robust hadith querying using knowledge graphs. So consider the following 2 examples. Typically, the researcher would like to evaluate or to check for the correctness and accuracy of a given statement. So in this case, we have Ibn Rajab. He's saying there are about 6 or 7 narrations that are accepted by Sufyan ibn Uyayna, from Zuhri, from Anas. So these are individual narrators, and there he's saying there are only 6 or 7 hadiths or narrations that are accepted. In another statement example, we have Ibn Hajar. He's saying the hadith such and such is one of the 4 hadiths where Imam Muslim has a higher rank, that's a shorter chain than Bukhari to the same source. Now, these are relational type of questions, and they can be quite complex when it comes to as a statement by itself. And there's no trivial way for users to verify these statements, at least not with the current tools. Current tools, they give you extensive ways to look for texts, and either you can even go for stripping the text with roots, with limits. Sorry. Right. And but none of them shows any way of trying to find anything that is relational among different domains. So since the query seems to be quite relational, we constructed an entire domain graph into 8 different dimensions. So we have hadiths that belong to a Takhreej group, which have a judgment that is interesting to the scholar. The hadiths themselves, they fall under specific topics, and each hadith has its own isnad, which is narrated by a sequence of narrators. Each narrator has some biographies, they mention them, and each biography has insights or scoops about their about details about the narrators. the queries can go anyway in any of these domains. So I could be asking, I want the hadith narrated by narrator X, who are having the same Takhreej group as the narrator Y, and I want one of them to be, for example, from Iraq or something. And these are not completely hypothetical scenarios. These statements do exist and they do have importance in this domain. So, well, since it's very relational, we thought that we can try the trend of representing information as knowledge graphs. So we built our own graph database, right, which is structured of simplified domain knowledge graphs. So hadith, they belong to Takhreej groups. Hadith, they have isnads. Isnads have a sequence of narrators. And yeah, if we just revisit the scenarios, the user needs in the use cases, it becomes very easy to retrieve in that case. Because now the same statement, so there are about 6 or 7 narrations accepted from Sufyan ibn Uyayna, from Azuri, from Anas. Well, you're asking about a hadith that has, well, narrators of these IDs in our database, which is very simple for anyone that knows Cypher and for example, Neo4j database to just query this statement. I'll come back to a challenge that is raised by this when I come to the conclusions later on. So can I verify this statement? Absolutely. It took us about 2 or 3 minutes to just type in this query, and then it loads up all of the instances, and turns out there are 8 different hadiths. So in this case, the scholar might be interested in saying, okay, why did Ibn Rajab say there are only 6 or 7? Were they not aware of the 8th one, or maybe they disregard the 3rd one as they reject the last one and not consider it to be one of the accepted ones. Similar thing for the second query. So in this second query, we're interested in Takhreej groups rather than isnads, as in the previous example. So I'm interested in hadiths or that are narrated by Muslim as well as Bukhari, but I want the rank of one of them to be higher than the other one. Again, it's a simple query that we can just run, and we can verify, yes, there are actually only 4 hadiths, as the scholar have mentioned. So with ease, this way, we reformulated the entire problem from a text-based retrieval to a whole knowledge graph retrieval strategy. In our second proposed solution for more robust retrieval in Hadith, we proposed a creating Takhreej groups using text-pair classification. So the current Hadith IR methods available so far are 6, and they all are limited due to, well, based on certain condition to be applicable. So for example, one of them is if I have an interesting narrator, then only I can, well, look for documents or indexes that documents for that particular narrator, or maybe there's an uncommon word or keyword in the text of the method. Therefore, I can look up for that one. And with applications using, well, applications that are currently available that utilizes, well, smart search engines, they just enhance these ideas to the next level. However, they are still quite limited with they cannot retrieve all of the instances of a particular story. And that's why we require usually annotators to come and say, oh, this text and that text, or this story and that story is actually the same. And they're all instance-based. Well, our goal is, or the user need is to have the entire group or the entire collection by itself. So again, the collection is the instance, or Takhreej is the group. Takhreej group is the collection of instances of the same matan, the same text, from different isnad, from different sources. Sorry, narrated by the same top narrator. The good thing is that Takhreej groups are actually static results. They don't change. It's for the same data set, they will be the same. So therefore, we don't need the user query in order to compute them, and they can be constructed offline the same way that we do for index, the same way that we construct an index for search engines. And then this can be modeled as a semantic similarity classification problem. However, this might be quite challenging because the number of classes available is quite a lot. So we have about 10,000 Takhreej groups of the 6,000 hadiths available in the 9 books hadith dataset. But we have plenty of data for any training for pairs. So this becomes about 500, more than 500,000 hadith pairs of the same Takhreej group. So this is exactly what we did. So we paired up Takhreej groups. We sampled about 200,000 pairs. 50% of them were of the same Takhreej group, so they are positive Takhreej group, and then 50% of them are negative Takhreej group, and therefore we just train a model to do a pair classification to determine if two instances are actually of the same Takhreej group or if they are actually the same story. We had to filter some of them, of course, due to the pair length, which is limitation of the model that we used. For your reference of how difficult this problem is, so when we initially did a cosine similarity of the pairs, it was quite challenging. We got about 60% of different of classification or accuracy of the classification, because there is a significant overlap between the vectors of the hadith themselves. So we split the pairs, the 200,000 pairs, into 80-20 split ratio for train and test. And we use transfer learning using a classification, using a transfer model, which is a BERT-based AraBERT, right? So it's it's an Arabic model for BERT that was trained on large Arabic textual data, and the results are quite good. So we got an F1 measure of 90% or 0.9 for both recall and precision. Training time was about 3 hours per epoch. I think we trained it for about 2 epochs, and the prediction of the test cases of 400,000 pairs took about 18 seconds or so. At the time of running, all we need to do whenever a user is interested for a new instance that we haven't seen, we can actually scan the entire dataset with ease. And in less than a minute, of course, it's gonna retrieve it's gonna classify that instance with all the instances available in the dataset and retrieve the ones that are that have a high positive Takhreej group classification. So in conclusion, this research aimed to address the foundation problem for Hadith IR, and we proposed 2 robust solutions to make the process more insightful. Our reformulation of the Hadith IR problem by building a knowledge graph and knowledge map was represented using graph databases, is much more expressive in terms of querying. So this allowed us to query a lot of things that the previous or the current systems and applications were limited to do. It easily overcame the limitations of the text-based querying available right now. Our presented work was used or was shown and presented and demonstrated to Hadith students as in our user study group, and received very good impressions in terms of the capability. The main challenge that they faced was that most of the users did not have the right literacy when it comes to using something as complex as cipher querying. However, so we propose that in the future, this can go into the direction of trying to simplify that graph querying design. By the time we finished this research, ChatGPT was a great hit, and Neo4j, the database management system for graph databases, they implemented a ChatGPT interface feature. This allows the user to translate natural language statements into necessary cipher. So we are working on adapting this as a main user interface. So this way, the user don't need to write cipher query directly. The literature also showed that there are relatively significant gaps in the manuscript digitization. So a lot of the hadith sources are still within a manuscript form and not even printed, and digitization in that case will be a great hit, as it will improve our availability of the data for research purposes. This goes the same for biographic data information. They are things related to our data about, or textual data about the narrators of the hadith, which is key for evaluating any sanad of any hadith or any sanad instance. The work of this research is quite unique. It explores a highly underexplored area for classical Arabic, and with very high potential. All of the datasets and code that we use in our experiments are well, they are the largest in size, first of all, and secondly, they are entirely available online through GitHub. Thank you all for listening. I'm here if you guys have any questions. Feel free to contact me on my email.